Welcome to Ask and Learn.
Alright guys, we're doing problem 120 in chapter 5 of Chemistry Essential Science. So consider the combustion of a single molecule of methane gas forming H2O as a product. How much energy in joules is produced in this reaction? So first we have to get our balanced combustion reaction. And now we're going to use Hess's law to figure out the delta H of this reaction. So 2. Don't forget that at Hess's law, delta H of reaction is equal to delta H of products minus delta H of reactants. So minus 285.3 minus 393.5 minus negative 74.8. Remember, O2 is oxygen into standard state, so its delta H is 0. So now we're going to plug everything into our calculator. That's minus 889.3. Yep. Kilojoules per mole. That's the delta H of combustion, but that's for 1 mole of our substance. We are dealing with 1 molecule. So remember Avogadro's number. 1 mole is equal. 1 mole is equal to 6.02 times 10 to the 23rd molecules. Joules. So now we're going to divide both sides by 6.02 times 10 to the 23rd. Third. So 1 molecule is equal to 1.66 times 10 to the negative 24 moles. So we're going to multiply 1.666 times 10 to the negative 24, and multiply that by our kilojoules per mole. That's minus 889.3 minus 1.47 times 10 to the negative 21, 1 kilojoules. So this is the amount of energy that's released from the combustion of 1 molecule of methane. And now part B, a typical X-ray source has an energy of 8 kilo electron volts. Is the energy released by the combustion of a CH4 molecule, larger or smaller of the energy from X-ray from this source. So we have 8 keV. We know the conversion from electron volt to joules. So multiply keV as 1.60 times 10 to the negative 19 joules over 1 EV. The EVs cancel out. The K stays the same, and so that turns our joule. That turns our joules into kilojoules. So so we can see that the energy we get from the X-ray is 12.8 times 10 to the negative 19th kilojoules. Now, the energy released from burning of methane is 1.47 times 10 to negative 21 kilojoules. So the energy we get from the X-ray is actually larger than what we're getting from burning our methane. It's larger by about us. We have us by a few orders of magnitude. 10 to the negative 19th is a greater order of magnitude than 1.47. 7 times 10 to the negative 21. So the amount of energy we get from our X-ray is larger than what we get from burning one molecule of methane.